All right. Well, welcome again to another edition of Not Your Father's Data Center. I am your host, Raymond Hawkins, Chief Revenue Officer at Compass Data Centers. Today, we are joined by the Editor-in-Chief at Space IT Bridge, Doug Mohney. Also, thank you so much. Doug,
Okay.
Thank you for joining me. And Doug, if you are willing, we'd love to hear you give us a little bit of background on yourself. I know that ultimately writing about data in space has been a bit of a journey for you going back to the IP days. So if you don't mind going back to the beginning, we'd love to hear your story.
Yeah, well, hopefully we don't have to spend 2 hours on my story. I started out with an internet startup back in the mid 1990s that went public. It was Digex in the Washington, D.C. area. And then after I got out of that internet startup, I went into another startup that dealt with the internet and satellites. So that kind of like meshed two worlds there for a while. And from there, the company, which started out as Skycache and got renamed Sidera just before it was supposed to go public, and then didn't go public due to the .com crash. I ended up switching careers from being in doing marketing and sales within companies to writing about companies. So I started writing about internet, data centers, and satellite stuff. And then somewhere in my head, I got it in my head that, hey, if I write about satellite stuff, then I can connect it to data center stuff. I could go to space launches and have an excuse to go to space launches. So that's kind of like where I ended up at Space IT Bridge today, talking about the intersection of space technology and IT technology, which not a lot of people are talking about right now. And I mean, people are starting to get savvy to the fact that there's a tremendous amount of data being generated by satellites today. And that number is, I don't want to say exponentially increased, but dramatically increased through the next several years as more companies put up constellations of satellites to observe the Earth and to do communications, to keep track of ships and planes, the IoT side of things. So there's a lot of stuff going on there.
So yeah, we're gonna dig into all that, Doug. So before we get, because I'm with you, Earth observation and shipping routes, all that stuff's all going to be great stuff we'll get to. So do me a favor, let's go back to Digex just for a minute. What the business there was strictly IP, managing IP circuits and those kinds of things.
Digex had two main businesses. They did connectivity, that is lease lines, connectivity for businesses. And then the other side of the Digex equation was web hosting, which evolved into the cloud today. So we were running servers for people like CIA, American Association of Libraries. Amtrak was one of our customers at that time. So there were a lot of good mix of government and commercial side people.
Gotcha. So yeah, Doug, we call it cloud today, but yeah, the concept of hosting your compute somewhere else is not new. And I certainly remember fondly the phase that we called hosting, web hosting and server hosting. So yeah, okay. So that's Digex was in the hosting business and the connectivity business. And then walk me through Sidera. I'm going to make sure I say it. Sidera Analytics. Walk me through that business.
Well, Sidera, the company, used satellite broadband in order to deliver bulk information to the edge of the internet, because back in, I'd say pre-2000-ish, the big issue was moving large or bulk data from where it was located at, meaning data centers and and the like, to the edge, to what we now call the edge. And satellite broadband was a way to deliver data directly to the edge without having to move it through terrestrial choke points or connection points. So at the time, it seemed like a really great idea until .com turned into .bomb, and a lot of the and then it was revealed that a lot of the hype about being their an infinite demand for fiber kind of died off. There's an oversupply of fiber. And then satellite just proved not to have the bandwidth in order to deliver bulk data that fiber did, as more and more people got connected to fiber at lower and lower cost.
Gotcha. And thus we see fiber everywhere today. So you can steer me away from this, but I'm going to have a hard time not asking you, when you have the Inquirer on your resume, just got to ask, what was the working at the Inquirer like?
Well, this wasn't the National Enquirer, but it was
okay, all right.
No. Enquirer.
I got you.
Which, UK Enquirer was a cheeky publication. They were fun to work with, and they would, they have that British sensibility or flavor of being a little bit snarky when talking about IT issues. So it was really fun working there. But no, it wasn't the National Enquirer.
Not that Inquirer. All right, good stuff.
I would be in recovery if I was working there. No.
All right, so a lifetime in technology, mostly networking, sales, and marketing. As that business matured, decided, hey, this is fun to write about this stuff. So give me a little bit of the personal background of what got you fascinated, because we make the jump from IT, sales, and marketing over to space. Your personal interest in space. What was the first thing that you said, hey, that's cool? Did you see a launch? What got you fascinated with space?
Well, like any child of the 60s and 70s, there was a big love of Apollo and a big love of going to the moon. And then, and then it evolved into, hey, the space shuttle is cool and astronauts are cool. So a lot of people from that generation, sorry, TikTok kids, we had a good foundation there. And I found that as the space shuttle program was winding down, I wanted to go see a space shuttle launch because I'd never seen a space shuttle launch. So there was this interesting confluence with the government-sponsored government push for space systems as it wound down. There was at the same time a start of commercial activities. Basically, how do you make money out of space without the space shuttle, or how do you make money out of space with off-the-shelf data? So, there's been over the past decade, there's been this mind shift in terms of how people think about space, and where in pioneers in the sector realized that you don't have to send up these big expensive satellites in order to make money. You can build smaller satellites, and smaller satellites mean that you can send them up cheaper. And if you can build satellites and launch them cheaper, you get into this, God help me, virtuous cycle that you can get more data. You collect, basically what it boils down to is basically you get more data back for less capital cost of launch and building satellites. So that's what a bunch of companies started to do, and then that whole ecosystem started developing. Like a lot of people building small satellites and building companies around them. And then today, now we have this proliferation of companies like Planet and Satellogic and Black Sky and tons of other people who are building satellites, building large constellations of satellites to collect data by photographing the Earth or whatever, and that got to be very interesting because now what they're doing is they're going public through SPACs and raising lots of money. So it's a very happening place to be right now.
Yeah, Doug, there's lots of course, visibility and conversation. I know our media darling billionaires keep shooting themselves into space, and everyone wants to watch that. So you wanted to see a space shuttle launch. You grew up, with the affections for the whole Apollo mission and how do we catch the Russians, and Sputnik scared everybody. I'm dating both of us with those references. And how do you make the leap? Where does space IT come into your purview, and you decide, hey, these guys are a great place where I can write about technology and write about space? How did that come about? And then I want to get into a bunch of the subjects you've raised.
Well, I think I got it. It just struck me, I don't want to say once a generation, but once a decade, you see a paradigm shift, right? We saw this with personal computers, right? Where blah, 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 we had all these junky well, not junky, but we had all these primitive personal computers. And then all of a sudden the IBM PC came out and bang, businesses they all had to get IBM PCs and they all had to get, and all of a sudden everybody had a personal computer within, I don't want to say overnight, within a 3-5 year period. It had to be the thing. Okay. Then from the 80s, we shifted to the 90s. And then you had the same phenomenon where the internet was this geek toy. And, where academics, academics were sending an email and, talking blah, blah, blah. And then all of a sudden, when the internet went commercial, for whatever definition of commercial, bang, 3 years later, you went from nobody knowing about the internet to going to your local football stadium and they're going www.redskins.com or, that's Redskins a wrong way, but you had companies, they all had to get on the internet in a very short period of time. And that was the 90s. Now we're in this period of a similar paradigm shift, if you'll forgive the analogies and buzzes, where we started off where satellites were very expensive. They were like mainframes, where it's very expensive to launch a satellite, very expensive to build a satellite, very awkward to get information from that satellite. So it's very costly. So you had this whole mainframe situation where satellites were this holier, resource. But the small guys, the CubeSat guys, the small sat guys realized that, okay, I don't need to build this $500 million satellite. I can build a satellite for under $1 million or less and get useful information out of it. So you all of a sudden had this shift from mainframes to cellular phones, in essence, where satellites became a very expensive commodity that like a mainframe where you ran it for a decade or more and milked that cow for every single bit out of it, to a cell phone mentality where you buy a cell phone, 3 years later you buy a new cell phone. In this case, you buy a small satellite. 3 to 5 years later, you throw it out and you launch the new one, and then the new satellites that you launch, since you're launching them more rapidly, you get that technology refresh. You get a constant technology refresh as you put and update your technology in orbit.
So those big earlier ones, am I putting those further out in orbit than these littler ones that you're talking about now? Do I want them out there further and sitting there longer? Is there a function? I mean, because we're talking about orders of magnitude, a $500 million satellite and $1 million satellite. I got to believe these have vastly different functions.
Well, they do, but part of that's physics. And when we talk about physics, we'll talk about the physical physics of moving things from point A to point B. In other words, when you build that $500 million satellite, in order for it to sit over one part of the Earth, you have to push it out 22,000 plus miles. And that costs you a lot of rocket fuel and a big rocket. So if you're going to go put it up there and it's going to be up there for a decade or more, that satellite has to work perfectly. That satellite has to be tested perfectly. And,
so the service calls 22,000 miles up aren't very regular, are they?
Yeah, that's correct. Yeah. Basically, fault tolerance and things like that are built into those types of satellites. Now, the other thing about physics is that since you're 22,000 miles out, you have this thing called lag, right? Where speed of light starts taking effect. So to go up and back from orbits, half second or more better. In terms of speed of light and in terms of, all the little nuts and bolts and turnarounds time. So that half second lag sucks.
That's if I'm moving at the speed of light, which radio transmissions or data transmissions don't. But go ahead. Yeah, I'm with you.
Well, yeah. Plus you get the overhead from data and packet logging. After that, half second starts dragging out a little bit more. But the other thing is that I need more power. Since I'm going 22,000 plus miles, if I'm using radio waves, I need a bigger antenna on the ground, number one. And up in the sky, I need a much larger, more powerful broadcast mechanism in order to get the signal down. So between those two things, again, that adds to, I need to have a satellite that has big solar arrays because I need the power, and I need bigger radios, so I need the power. So all those things add up to a fact that, geosynchronous orbit, those initial satellites were great in that you could put up one and serve a good chunk of the Earth, if not half the Earth, depending upon what radio frequencies you did. Okay, so putting up a small satellite closer to the Earth gives you a lot of benefits. Okay, instead of 22,000 miles away from the Earth's surface, if you fly a small satellite lower at a couple hundred miles, you don't need the big radios. You don't need the big antennas on either end. All of a sudden, you can do useful work with a satellite that 400 miles and is the size of a box for a wine bottle. 30 centimeters by 10 centimeters by 10 centimeters.
Really? That small?
Well, that's kind of like the benchmark. And that's really big for some satellites. There are companies that are pushing that and going from that wine box size down to smaller. Like, for instance, Swarm Technologies has a satellite to do IoT stuff. We're not talking broadband or anything like that. But Swarm Technologies has a satellite to pick up data from IoT sensors that's the size of a piece of Texas toast. It literally is 10 centimeters by 10 centimeters by a quarter centimeter. And it's packed with radios and power and intelligence.
Doug, anytime we can work Texas toast into a podcast, I think we've been successful. We've had a good podcast, so thank you for that.
Okay. So now I just got to work in donuts, and I'll be happy.
That's right, exactly.
But the thing is that, to borrow from Jerry Pournelle, there ain't no such thing as a free lunch. In low Earth orbit, the satellites are moving faster. They're not so. So if you're out of geosynchronous orbit at 22,000 miles away, the satellite moves in a rough orbit at the same time as the Earth rotates. So it's always, there's this illusion of a fixed position. If you're in low Earth orbit, those satellites, since they're lower, they zip around faster. So a single satellite zips overhead, and maybe you see it for 5 to 10 minutes a day, twice a day for a single satellite. But since the satellites are cheaper, you can build a bunch of satellites. So you've got a satellite zipping overhead, every time you need it, essentially, if you can launch enough satellites.
So two big questions, just as a layperson trying to understand this, Doug. Just help me with a couple of things. One, I got to believe that my field of vision, my field of view at 22,000 feet is radically different than my field of vision at 22,000 miles than it is at 400 miles. So I'm getting a smaller slice. I'm getting a smaller picture. Am I accurate in that? I got to be getting a much smaller view of the world at 400 miles than I am 22,000.
Well, yeah, but I need a smaller camera to see if we're talking about imagery, I'm a smaller camera because I only have to focus on something that's 400 miles away versus 22,000 miles away if we're talking about imagery, right?
Right.
And
for Earth observation, sure, right.
Yeah.
And then you've used this term, and I've read it before, constellations. Is that literally what I think it means? So there might be a train of 100 of these that are flying in some sort of controlled format or fashion? Is that what we're talking about, or is it bigger than that?
Depends upon the application. Like, for instance, I'll give you the for instance. The for instance is that if you're talking about communication satellites, things like SpaceX Starlink or the OneWeb constellation, SpaceX has over 1,500 satellites right now to deliver broadband to the entire world. Okay. OneWeb is in the process of filling out their constellation. They're at 300 plus satellites, and they'll scale up to about 648 or so satellites to provide broadband coverage to the entire world. But, broadband's kind of funny in that you want to have it on all the time. So you need a satellite you can reach all the time over you above. For other applications, you can start off with a few satellites, and as more people get onto your service, you launch more, and then your coverage time, to take pictures of the world gets a lot better. So um, like if I put up a dozen satellites in the world, I may to take pictures to collect imagery. I may be able to visit places on the Earth maybe 3 to 4 times a day. But if I increase that number from that handful of a dozen or so up to 300, all of a sudden I could take pictures of anywhere in the world pretty much 24/7.
Yeah. So Doug, you used the term. You said they want to deliver broadband anywhere. So are we literally thinking that we're going to deliver internet services bouncing up into space and back all over the planet? So when I go to sub-Saharan Africa, and I can have internet service there via satellite?
The short answer is if they have the licensing, it's all about the politicians. I mean, you could do that today in sub-Saharan Africa if they had landing rights. In other words, broadcast permissions to operate within there. Yes, you could have depending upon what network you have, you could have. Well, we'll use SpaceX as an example. SpaceX could give you up to 300 megabits a second broadband into a 1 meter or less than 1 meter ish dish, right? And you can get up to 30 meg upstream today.
Wow.
But but remember, that's optimal. If I'm not quite,
if I'm not perfectly aligned, right?
If I'm not perfectly aligned, or there's trees that you haven't managed to chop down, or other crap in the way, then that's going to go down. But if you go to Reddit, don't believe me, believe Reddit. If you go to Reddit, there are users getting over 300 megabits a second downstream, coming down from the sky.
And
30 megabits.
So how does that, Doug? How does that get worked? Because I know we, here in the U.S., we manage the spectrum via the FCC, I guess, right? Manages the spectrum and sells that spectrum. Is when we're going up in space, do they then take over the spectrum management once you get back inside the atmosphere? When you get over, how do they manage that? Because you used, hey, if there were the appropriate licenses. So I got to imagine I've set up this constellation. I'm spinning satellites around the Earth. I got all this bandwidth. I can stream it down to guys who have my dish. But a guy in New Jersey and a guy in Nairobi are getting totally different experiences from a regulatory perspective. But conceptually could get the same experience from a bandwidth perspective.
Well, from a regulatory perspective, then it's legwork. SpaceX has to go around, or whatever the satellite broadband carrier is, has to go around and do the legwork with the local authorities, because the local authorities control the radio frequencies within that nation, right? So basically, SpaceX has to go to that country and go, "Hi, I'd like to operate in your country," and then work it out so that they get what they call landing rights. In other words, permission to operate within the country.
Right.
Landing
rights. Okay.
Yeah. So SpaceX has landing rights, or the ability to operate and sell dishes. Well, operate and sell dishes in pretty much most of Europe, parts of Africa I've seen, and definitely Australia, and I think some parts of Asia. I'm not exactly sure. There are places where SpaceX will not operate due to government control, like Russia or China.
I can think, yeah.
Russia and China are very problematic, and because I'm not, but who knows? They might get you pay enough people and you have enough lawyers, anything's possible from a political standpoint. But for right now, I don't see SpaceX operating within China or within Russia. So because there's no desire, I think Elon Musk likes things simple, and having to deal with Russia would give him certain headaches, since he's also selling to Department of Defense.
Right. So, Doug, as I think through this, so I've been to sub-Saharan Africa, I've been to Kenya and Uganda and South Sudan, and my first trip ever there was really mind expanding for me. I walk into a village, there's no paved roads, there's no sanitation, there's no two-story buildings, there's not an inch of concrete sidewalk anywhere, and yet people were walking up to me with cell phones. And I was like, wait a minute, there's no infrastructure here at all. How do you have a cell phone? they would walk with me out to the edge of town and show me the cell phone tower that was out there running on batteries and running on a generator. And I was like, okay, that's interesting. I get how the tower, how are you running your phone? And they had car batteries with this contraption set up on top of it, and they would plug their cell phone into a car battery. And they just completely skipped over the whole landline delivery of telecom in those countries. They're like, hey, we had gotten so far down the path with cellular, we didn't need landlines. Is this the same thing when we think about delivering broadband to those places?
Well, it's an interesting trap, and I don't want to say trap, but um, if I want to address the meta point that you brought up about Africa. If you take a look at the different fiber projects Google is starting to run into Africa, and the different fiber projects that there's like a big fiber loop. I think that was built by French Telecom, that runs around Africa, and then you get spurs off going into each countries. Fiber sooner or later shows up, and I'm not saying that that the place you visited in sub-Saharan Africa, I don't know however many years ago, or if it was recently, but I'm willing to bet that sometime in the next 10 years or 20 years, that cell tower eventually gets hooked up with fiber, because you're going to need more broadband in order to service the next generation of phones and to service the expanded services that you're seeing bootstrapped off of simple cellular services. So I'll leave it at that point for now. Now, let me shift gears here and talk about how satellite is going to help connectivity. Like that cell tower you saw in sub-Saharan Africa, it's being backhauled somehow, right? And that backhaul may be fixed point-to-point wireless today, right? And so in essence, you need a network or a string, right? A string of tower here, tower here, tower here that talk to each other. The nice part about satellite, and there's two kicks to this. One is that you can use satellite broadband that's just coming out. That's going to be low latency because it's close to the Earth. So instead of that half second plus of overhead you have with geosync, you have that tens of milliseconds latency delay because you're closer to the Earth. So things like SpaceX and other people in the LEO space delivering broadband will give you what I'd say near fiber quality, although that's marketing. We're not really sure, but near fiber quality delivery of broadband to anywhere in the world. So you could, in a place in sub-Saharan Africa, set up a cell site outside of normal coverage, and its backhaul is not fixed wireless point to point, but its backhaul is up to the satellite, and then you get connected into the cellular network via satellite backhaul, and that's really promising for like there's big plans in closer to here in Canada to use LEO broadband satellite to do backhaul, cellular backhaul in Canada. And then you've got folks like Bharti Airtel working with OneWeb to do backhaul in India, Africa, Asia, and other developing world markets.
So for my friends who don't know the acronyms for space, LEO is low Earth orbit. So
Yes.
Which is when you're talking about 300-400 miles up, it's low Earth orbit stuff, low latency, close to the planet stuff.
Yep.
Yeah. Gotcha.
And geo
Awesome
meaning geosynchronous, very far away.
Yeah. So Doug, another thing that I don't know of a simpler way to ask it. Who's putting these satellites up there? Because I think of satellite stuff, and I think about it from a government perspective. I think about it. You referenced the shuttle program. I think of people putting things in space are government entities because of the sheer cost of the technology and the sheer cost of propulsion and the rockets, and all of it is expensive. But that has changed in the last 7-10 years. So who's putting satellites up there today? And are we getting rockets lifted off the planet on a regular basis other than just the ones with William Shatner and Elon Musk in them?
Okay. Let me deal with the hype, and then we'll go with the reality. And I don't want any hype, but the problem is that there's been a media obsession or media focus with Jeff Bezos and Elon Musk and Richard Branson as the fighting billionaires to basically throw people up into space for a minute and a half and then bring them back down, and then collect their $250,000 for a 10-minute joyride. And that's cool, but that's not where the money's being made. SpaceX is launching rockets on a regular basis. Basically, they get ride share. They do a ride share where they get 20, 30, 40 companies, and they put them on top of a Falcon 9 rocket. And SpaceX is launching at least three times a year, these dedicated ride share missions to throw up 20, 30, 40, 50 50 commercial satellites at a time in order to build out these constellations. But all the money, but to answer your question, who's paying for it? It's a mixture of commercial investment and some subsidies from the government.
Okay. But all those companies that get on that Falcon 9, they're all paying some fee. And the business model for SpaceX is we generate enough fees that we cover the cost of design, development, and deployment of the rocket.
Yes. And right now, SpaceX SpaceX is making money because they built the rocket. They know how to build the rocket. The rocket works. And oh, by the way, the first stage flies back. So there's an initial cost. So they can refly it, refuel it, and then send it back up a couple of weeks or a couple months later. So they can reuse the rockets. It's not like, you used to pay, if you want a shiny new Falcon 9 and off the line, it costs you like $60 million for a flight. But SpaceX gets back that first stage. So it costs them it's much less to launch things up into orbit now because they reuse the first stage. And the first stage, and the thing that people, if you think the thing is a first stage, since that's providing most of the power to get things moving fast, the first stage has some very expensive engines in it. And there's not like the SpaceX, the Falcon 9 has 9 first stage engines, very, very expensive. So if I get the most expensive bits back and I can reuse them, then hallelujah, my cost to launch significantly goes down. For launch, SpaceX, for instance, they've launched the Falcon 9 first stage, or reused the Falcon 9 first stage up to 10 times so far. So it's not, they used to do it 2 or 3 times and they'd be like, oops, and then it crashed once. But now they're up to the point where, or they realized that they couldn't, it's been evolution. It's like first we had our clunky PCs, now I got my nice Dell sitting on here that does gaming. Similarly, the initial Falcon 9s, you get 2 to 3 flights out of them. Now the Falcon 9, they can get up to 10 flights out of them, and SpaceX has said that they may be able to squeeze more than 10 flights out of them in future models that roll off the production line.
That's awesome. 10, I mean, so that's an incredible change to the economics if you can use the thing over and over 10 times. It just fundamentally changes it. So let me ask you, and I may drive us down a ditch here, I apologize. Are we getting better at the fuel that we deploy in this? Because I've always understood that the fuel, the amount of propulsion compared to the weight of the fuel was always tough. Are we getting better at the fuel for these rockets?
Well, I think that, but cost of fuel is a fractional.
Yeah, not from a cost. I mean, weight, the cost of how much propulsion we get versus how much weight. Because, right, we're moving every kilo you move out of Earth orbit, there's amount of propulsion you have to move. Well, some of that is the weight of the fuel. That's what I'm asking. Are we getting better at the ratio of the weight of the fuel to the amount of propulsion we get out of the fuel?
We've got some better optimization, yes, and but I don't, we could nerd down this for a while, but, in the bigger scheme of things, when it costs you, $60 million to build a shiny new Falcon 9, right? And that includes the launch cost. Launch cost for the fuel is probably a couple $100,000 of.
Okay, so it's not a big part of the problem anymore.
Couple 100,000. Well, yeah, because you're talking about a couple $100,000 in basically kerosene, JP4, jet fuel. Basically highly processed jet fuel and liquid oxygen.
Gotcha.
So
it's not a big. When we're looking at the equation, it's not a big enough problem in the equation anymore for us to spend a lot of energy on. Got it.
For moving anywhere from anything all the way up to geosynchronous orbit, it's not a problem. You want to go to you want to go to the moon, then you start getting into refueling and mining stuff and mining asteroids for oil, not for all, mining asteroids for ice. But right now it's not a big deal in the bigger scheme of things.
Okay, that's what I wanted to hear. It's not a big deal. And so here's my next question. Talk to me about business applications. Who's getting? I mean, so I got why I need broadband, and somebody's going to pay me for that broadband connection. I got that business model, but that's just one of them. Give me a handful of other business models of why having satellites in space close by in LEO that allow me to make a real business case for what I'm doing up there.
Okay, the best example that I can give you brings in a bunch of stuff, and I don't want to play the African card, but I got to play the African card. I was at a conference about a month ago, and there was a company that does data analytics, and they started talking about how they monitor pipelines in Nigeria for theft, oil pipelines because oil's a big deal. Oil money fuels the government. So somebody coming in and sneaking in and pirating oil out of the pipeline is a bad thing for everybody. So the person telling this story says, well, here's what happens. First of all, we tap into the commercial satellites that are available today to monitor radio traffic on the ground. So they have a trio of satellites operated by a commercial company that fly over the Nigerian pipeline area, and they listen for anomalous radio traffic. What do I mean by that? They listen for handheld radio traffic in the middle of nowhere, essentially. Because if you're in the middle of nowhere next to a pipeline in Nigeria, if you're not a guy, if they don't have people driving the pipelines up and down all the time. So if there are people using VHF type of handheld radios near a pipeline, well, maybe there's something funny going on there. We need to have a closer look. So having that indicator or that piece of information saying there's some radio traffic here, we don't know exactly what's going on, but we want to look for other pieces of evidence to indicate if this is legitimate or if there's something going on, if there's something illegal going on. So that information runs from one computer model, and there's a machine-to-machine communication, or however you want to call it, where a message goes to a satellite tasking website, and it goes, we need you to take pictures of this area of interest because we don't know what's going on there. So there might be messaging going to optical satellites that is visible, and there'll also be message going to a radar satellite. So then the AI, and this all happens with magical AI. No, but this all happens via processes. So the satellites are automatically tasked to fly over this area of interest where there's radio activity, not radioactivity, radio activity.
Yeah, radio activity. I got it. Yeah, got it.
Over the pipeline to look at it in radar and look at it in visual. Now, the visual people are looking for, the visual and the radar satellites are looking for two things. They're looking for a boat nearby, because usually a pipeline is near a waterway, or they're looking for a barge. Because if you're going to steal a lot of oil, you either need a freighter or you need a barge with a bunch of barrels on it. So what happens is the pictures come in, the AI looks for images of barge or image of boat. And if there's a boat nearby and there's boat nearby, and if this boat doesn't have its transponder turned on, meaning that it's a dark boat, meaning it's doing something illegal, all of a sudden it's like, hey, we need to call the authorities because somebody's stealing oil out of this pipeline. And
wow, all from space.
All from space.
Yeah.
because you've got because you've got the radar satellites, you've got an optical imaging satellite, you got an RF satellite that's listening for radio signals, and then you've got a fourth pair of satellites that are looking to see if that boat is transmitting its transponder signal, and and all this is automated via AI. And I mean, there'll be alerts sent out on, somebody will get alerts, and at a certain level of activity, a human being will get involved, and they'll basically take the data, the information, and call the authorities and going, hey, we got something that we think's going down here. Can you send somebody out to drive out there or fly over there and see if there's theft?
What a great real world example.
And it
pipeline security.
And not only that, but the fascinating thing here is that I mean, if you take a step back, is that it's a beautiful example, but it's also a beautiful use case on you're doing multiple source information, right? You're using AI or machine learning to listen for or look for activity and process the imagery to actually look for boat, look for barge, and you're using AI basically to walk through that. It's all machine learning. It's all AI that's collecting the information up until the point where there's an email going out to like the Coast Guard, the local Coast Guard in Nigeria, or the local customs agency in Nigeria going, hey, there's theft here. You need to go, we think there's theft here. Here is the evidence we have. So, yeah.
Wow, fascinating example.
Yeah.
Data in space, saving pipelines everywhere.
Well, I mean, but if we throw out the pipeline example, we're only scratching the surface of what's going on. We can take multiple sources of data and mash it and apply it. I mean, this is equally applicable for, looking at after a hurricane. You can fly out and look at what infrastructure's been damaged using satellite imagery. If you're getting satellite imagery every couple of hours, you can fly out and see, what telephone poles are down or what, where the damage is in specific areas. Like insurance companies are going to be tapping into this information. Rather than send out agents, they'll be able to do a before and after picture. They'll take, they'll have imagery on file where they'll pre-hurricane, and then they'll be able to take imagery post-hurricane or post other natural disaster event and compare the two and go, aha, okay, these buildings are a total loss. We just need to write checks and not send anybody out there. And then these buildings, we need to send out an agent to evaluate to see if they can salvage. But I mean, again, there's a lot of information that you can collect from the sky, and we're just tapping into the individual bits and pieces of it. And the more information you get, you can meld them together, like a pipeline example, in order to do useful work.
Yeah, fascinating stuff. Well, Doug, this has been super helpful. We really, really appreciate you joining us. Thank you for getting on the podcast and talking about space and talking about data in space, and look forward to seeing as things continue to change, as we get more constellations and more applications, and it continues to change. I go back to the first time we broke the sound barrier and remember that, and now think about where we are. It's been an incredible journey for what we do up there.
Well, I think the thing that people lose track of is, I give you my two examples here. The SpaceX launch that was done over the summer, the satellites on board are collecting multiple terabytes of information a day. Multiple terabytes of information per day. So that means that by the end of the year, you've added a petabyte plus of useful information, and that only increases over time. That's just one launch. And as these people go from dozens of satellites in orbit to hundreds of satellites in orbit, you get this dramatic scale of information we're going to be able to collect about the rest of the world. It's going to be very cool.
Well, I'll just say this: as a guy who builds warehouses for data, the fact that we're collecting data from space is a good thing for me. So I'm happy about that.
Yeah, you're gonna. Well, what's fun too about that is that some of your customers will start tapping into that data, and all of a sudden it'll be like, oh, well, we need to buy more disk space, or we need to build a hyper scalable AI in order to process this information. So you get a couple of those customers, and it'll be, you'll need a couple more warehouses plus.
Thank goodness. All right, parting question: favorite Star Wars and favorite Star Trek episode. And when I say episode, of course, I mean the TV show. So favorite TV episode and favorite Star Wars movie.
Okay, you're hurting me real bad. All right, we're gonna go with Star Wars first. You have to go with the original Luke Skywalker, Han Solo, because that set the universe, that set the character.
Here, and absolutely number one.
And it was a beautiful genre because it laid the foundation for everything else, and just blew everybody's mind.
Yeah.
Star Trek is a lot harder because you start. Are you talking original series? Are you talking TNG? Are you talking Discovery?
So there's all kind. I'm going with the 3 years on television original series with William Shatner. Best episode in Shatner's 3 years on TV. And there's several to choose from.
I know, and it's really hard. I mean, Edge of Tomorrow, probably. I'd say
that one's good.
Edge of Tomorrow, and I can't remember the name of it. The one with Khan. And I can't. Space Seed. Was it Space Seed?
You got me on the name, and I'm not going to remember the one with President Lincoln, where he's the guy can make Shatner's voice, and Spock's dying, and they have multiple historical characters. I can't remember that episode. But that's one of my favorites. I can't remember the name of the episode, but love the original Star Trek.
Yeah, definitely. But we could spend another half hour talking about all the.
We'll have a whole episode just on Star Trek.
I'm just going to
you can come back and just do Star Trek.
I'm gonna throw out as my parting thought on your question that I have a really soft spot for Lower Decks because it's funny as hell.
Yeah, that's good.
I really like Lower Decks.
I watched Star Trek as a kid and thought, what are they doing walking around with these things that they talk into and they can hear other people? There you go.
And now
Doug, thank you so much for joining. That's right. That's right, me. That's right. Live long and prosper.
All right.
Good stuff. Thank you, Doug. We appreciate you joining us.